Today we will discuss about the iron-carbon phase diagram. Iron-carbon phase diagram is one of the most important binary phase diagrams in engineering. It details about the existence of steel and cast iron. Now, why it is so important? Because steel is one of the most used structural material in engineering, and therefore it is essential for an engineer to have the knowledge of iron-carbon phase diagram. For that we must have a little bit idea about invariant reactions. In binary system, whenever we will represent invariant reaction, it will be in the form of a straight line. So in iron-carbon phase diagram, we are having totally 3 invariant reactions, and therefore sometimes it is known as one of the most difficult binary phase diagram to draw. So as usual, in any phase diagram, the y-axis will be the temperature, the x-axis will be the composition, so the phase diagram is nothing but a box-like structure, and from this box-like structure we usually get the information of various phases in the material. So here this will be nothing but our composition. So iron Fe3C. So the maximum solubility of carbon in iron will be 6.67%. Beyond that, if we will try to mix the carbon in iron, it will not be dissolved properly. So therefore, though this goes till 100, but engineering point of view, we consider it till 6.67% of carbon. So as I told, we are having total 3 types of invariant reactions. The first reaction is known as Peritectic reaction. So what is Peritectic reaction? It is nothing but when liquid combines with solid, it will give you another solid. So we will represent this peritectic reaction on iron-carbon diagram first. So this is your temperature. Y-axis is nothing but temperature, and as we know, the melting point of iron is pure iron is 1538 degrees centigrade, right? So nearby 1494 degrees centigrade, this peritectic reaction takes place, and below that 1394 degrees centigrade, the solid state transformation begins. So as I told, that any invariant reaction will be represented by a straight line in binary system. So suppose this one is your invariant reaction. So it will have 2 ends. One end will have delta Farad, and this one is nothing but your liquid. So this line is nothing but our peritectic reaction line, or you can say peritectic isotherm. So we will simply join the nodes. Now, so here this will be nothing but iron will be in liquid, or you can say L. So this is our pure form of iron, that is delta ferrite. So this section, this phase will be the intimate mixture of delta ferrite plus liquid. Now here the combination, the mixture of delta ferrite and liquid will give you a point which is known as Peritectic point. So at this point we'll get another solid. So I will discuss it first. Join the notes. Right. So this solid will be nothing but your austenite. And the carbon percentage in austenite will be 0.18%. Austenite is represented by gamma. I will write the reaction here. So liquid plus solid will give you solid. So liquid L with carbon percentage 0.55%, when it will mix with ferrite, which will have the carbon percentage 0.08%, at 1494 degrees centigrade. Upon cooling, this mixture will convert into austenite, that is nothing but gamma, and it will have the carbon percentage 0.18%. This is our peritectic reaction. The second reaction which comes in iron carbon phase diagram is known as Eutectic reaction, and in this reaction what happens actually, the liquid will break down into two solids, solid 1 plus solid 2. Actually it happens at the temperature of 1148 degrees centigrade. So let's mark it on phase diagram, that is 1148 degrees centigrade, and then draw a line. As I told, invariant reactions are represented as straight line in binary system. So this will be your eutectic isotherm or eutectic reaction. Now we will join the notes, then we will discuss further. So here iron will be present in liquid form, so this will be liquid L. Here the percentage will be 4.3%, and this liquid, upon cooling, it breaks down into two solid. One solid is in left hand side, another solid is in right hand side. I write the reaction. Okay, so liquid L, that is 4.3% carbon, upon cooling at 1148 degrees centigrade, upon cooling breaks down into solid one, that is nothing but the austenite, having carbon percentage 2.1% plus solid 2, that is cementite Cm. Let's represent cementite from Cm, having carbon percentage 6.67%. So basically cementite is nothing but the iron carbide. It's a compound, interstitial compound of carbon in iron. Is having the fixed carbon percentage, that is 6.67, and this is the rightmost line, vertical line represented in the phase diagram. So in eutectic reaction, liquid will break down into two solids. One is austenite with 2.1% carbon, and another one is cementite with 6.67% carbon. Now before going to the next one, let's name all the boxes, or you can say phases. So this one will be your, as I mentioned, this one will be your pure form of iron, that is at higher temperature, delta ferrite. This one is your austenite. So this phase will be the intimate mixture of alpha ferrite plus austenite. Similarly, this phase, I mean right side of the peritectic point, will have the mixture of austenite plus liquid. So at peritectic point we had the solid, that is austenite, and to the left side of the peritectic point we'll have the mixture of alpha ferrite plus austenite. Similarly, to the right side we'll have austenite plus liquid. Now here peritectic reaction gets completed. Coming towards eutectic reaction, this phase we have already named it. This phase will have liquid plus Fe3C. This point is known as eutectic point. Eutectic point, and as I told that liquid will break into two solids. So in a reverse manner we can say that eutectic point is the intimate mixture of austenite and cementite. So this intimate mixture gives another phase, and that is known as ladeburite. We can represent it as LD. So here we are getting the intimate mixture of austenite and cementite, that is nothing but the ladeburite. Now let's go for the third reaction, that is known as Eutectoid reaction. So in this reaction actually what happens, solid breaks down into two solid 1 plus solid 2. This third reaction, Eutectoid reaction, happens at the temperature of 723 degrees centigrade. So let's mark it, 723 degrees centigrade. Let's draw a line over here. So here austenite gamma with carbon percentage 2.1% at 723 degrees centigrade. Upon cooling, it will start converting into alpha ferrite plus cementite. So here alpha ferrite will have a carbon percentage of 0.025. Similarly, cementite will have 6.67% carbon. So let's connect the nodes. So the carbon percentage is here, that is 2.1%. Upon further cooling, this solid will break down into, that is, alpha ferrite and cementite. So this is nothing but our alpha ferrite, pure iron at a lower temperature, and it will have, that is, 0.025% carbon, and as usual this one will be cementite. Now this is known as Eutectoid point, and this isotherm is known as Eutectoid isotherm. Eutectoid is the intimate mixture of alpha ferrite and cementite, and it is known as perlite. So this is known as perlite. So let's represent it as Pe, perlite. Now if you see this box, left side of the eutectic point, we will have the mixture of alpha ferrite plus perlite. Similarly, right side of eutectic point and before 2.1 line, this line, this is 0.8% carbon, and this one is 2.1, this one is 4.3. We'll have the mixture of perlite Pe plus cementite Cm. Now here we will have the intimate mixture of alpha ferrite plus gamma, that is austenite. Similarly, this side before 2.1 we will have austenite as usual and plus cementite. Now let's discuss the same thing about eutectic point. So this is nothing but your ladybutyrite, that is Ld. So towards left hand side of eutectic point we will have intimate mixture of austenite plus Ld. Similarly, in the right hand side we will have the mixture of cementite plus Ld. Upon cooling here, we are seeing that austenite is getting converted into perlite. Similarly, for this entire region, we are having austenite here, and ladybutyrite is a combination of, is an intimate mixture of austenite and cementite. So we are having austenite here also. So austenite in the whole will get converted into perlite Pe. Will also have cementite Fe3C plus transformed Ld. Similarly, this side also cementite will be as usual there. Ladybutyrite, the austenite in ladybutyrite will get converted into perlite. So therefore we will have the intimate mixture of perlite, cementite plus transformed ladybutyrite. This is our iron carbon phase diagram.